We have detailed maps of Mars. NASA satellite images show the surface of Mars mapped in extraordinary detail with craters, valleys, and mountains clearly visible. We have detailed maps of the Moon. We have detailed maps of Venus. We have mapped the surfaces of moons orbiting Jupiter and Saturn at resolutions that allow individual geological features to be identified. And the ocean floor of our own planet, the surface beneath 71% of the Earth, is less well mapped than all of them. Approximately 80% of Earth's ocean floor has never been directly measured. The maps we have of most of the ocean floor are estimated from satellite gravity data measurements so imprecise they can miss underwater mountains the size of Mont Blanc. A mountain as tall as the highest peak in Western Europe could be sitting on the ocean floor, and our current maps would not show it. The most unexplored geography on Earth is not in space. It is right here, beneath the ocean, on our own planet. And the 20% we have managed to explore has already produced some of the most extraordinary geographic discoveries in the history of science. The longest mountain range on Earth, the deepest point on the planet, an ecosystem that rewrote the entire understanding of where life can exist, and a geography so active and so dynamic that it literally creates new ocean floor every single day. Today, Where on Earth reveals the geography of the ocean floor, the world beneath the water that covers most of Earth and that almost no human being has ever seen. Subscribe to Where on Earth and hit the bell. Now let us go down. A cross-section diagram shows the different geographic features of the ocean floor, from the continental shelf to the abyssal plain to the mid-ocean ridge to the deep ocean trench. The ocean floor is not a flat, featureless plain. It has the same variety of geographic features as the land surface above water: mountains, valleys, plains, canyons, volcanoes, cliffs, but at a scale that dwarfs anything on the continents. The geography of the ocean floor is divided into several distinct zones. The continental shelf is the shallow submerged extension of the continental landmass. It slopes gently away from the coast to depths of approximately 200 meters. The continental shelf is geologically part of the continent. It was dry land during the last ice age when sea levels were 120 meters lower. The Doggerland that we covered in our earlier video, the lost country beneath the North Sea where Britain was connected to Europe, was on the continental shelf. At the edge of the continental shelf, the seafloor drops steeply down the continental slope. The continental slope descends from 200 meters to approximately 4,000 meters depth. At the bottom of the continental slope, the ocean floor levels out into the abyssal plain. The abyssal plain is one of the flattest surfaces on Earth. Vast expanses of deep ocean floor covered in fine sediment that has drifted down from the surface over millions of years. The abyssal plains of the Pacific, Atlantic, and Indian Oceans stretch for thousands of kilometers at depths of 3,000 to 6,000 meters, almost entirely unexplored. Then rising from the abyssal plain, the most extraordinary geographic feature on Earth. A cross-section shows the mid-ocean ridge rising from the abyssal plain with a central rift valley at its summit. In the 1950s, scientists conducting sonar surveys of the Atlantic Ocean floor began to notice something unexpected: a chain of underwater mountains running down the center of the Atlantic, from north to south, following the coastline of the continents on either side. As more surveys were conducted, the true scale of the discovery became clear. The underwater mountain chain was not confined to the Atlantic. It ran through every ocean on Earth, connected. A single mountain range zigzagging across the entire planet like the stitching on a baseball. The mid-ocean ridge system, 65,000 kilometers long, 1.5 times the circumference of the Earth itself. It is the longest mountain range on Earth by a factor of more than 10. The Andes, the longest continental mountain range, stretches approximately 7,000 kilometers. The mid-ocean ridge is 9 times longer. The mid-ocean ridge runs through the center of the Atlantic Ocean. It runs through the Indian Ocean. It runs through the Pacific Ocean. It runs through the Arctic Ocean. It is connected everywhere. One continuous mountain range beneath every ocean on Earth, and 90% of it has never been directly seen. Now let us understand what the mid-ocean ridge is and why it exists. The mid-ocean ridge is created by tectonic plates moving apart. Where two tectonic plates diverge, pulling away from each other, the gap between them fills with magma rising from the Earth's mantle. The magma erupts from volcanoes along the ridge crest. It cools. It solidifies into new ocean crust. The new crust pushes the older crust outward on both sides. The ocean floor spreads. New ocean floor is being created along the mid-ocean ridge continuously. Right now, as you watch this video, new basalt rock is solidifying on the ocean floor along the mid-Atlantic ridge between North America and Europe. The Atlantic Ocean is getting wider by approximately 2.5 centimeters per year. The same process created the Atlantic Ocean itself. 200 million years ago, the supercontinent Pangaea began to break apart. A rift opened in the center. Magma filled the gap. New ocean floor spread outward. The Atlantic Ocean was born. It has been spreading ever since. The mid-ocean ridge is the engine that creates new ocean floor, the factory where the surface of the Earth is continuously renewed. Now let us understand the deepest geography on Earth. Deep ocean trenches form where one tectonic plate dives beneath another in the subduction zones we covered in our Cascadia and Juan de Fuca videos. Where oceanic crust is subducted beneath continental crust, the seafloor plunges to the greatest depths on Earth. The Mariana Trench in the western Pacific Ocean is the deepest point on Earth. The Challenger Deep at the southern end of the Mariana Trench reaches a depth of approximately 10,935 meters, almost 11 kilometers below sea level. If you placed Mount Everest at the bottom of the Challenger Deep, it would still have more than 2 kilometers of water above its summit. Fewer people have descended to the bottom of the Challenger Deep than have walked on the surface of the Moon. 12 humans have walked on the Moon. Approximately 8 have descended to the Challenger Deep. The deepest point on our own planet is less visited than the surface of another world. The pressure at the bottom of the Challenger Deep is approximately 1,100 times the atmospheric pressure at sea level. It was assumed for most of human history that the deepest ocean was essentially lifeless. Too dark, too cold, too much pressure. Nothing could survive. Then in 1977, scientists changed everything. A submersible descends through dark ocean water toward the ocean floor at depth. Geologists aboard the research submersible Alvin descended to the Galapagos Rift, a section of the mid-ocean ridge in the Pacific looking for hydrothermal activity. They were expecting hot springs. What they found was an entirely new world. Rising from the ocean floor were towering chimneys of mineral deposits, some as tall as a 15-meter building, belching superheated black water into the surrounding cold ocean. The water emerging from these chimneys, called black smokers, reached temperatures of up to 400 degrees Celsius, hot enough to melt lead, in water under such extreme pressure that it remained liquid despite exceeding the boiling point. And surrounding these chimneys was life. Not microbial life, complex ecosystems. Giant tube worms 2 meters tall, clams the size of dinner plates, shrimp, crabs, fish, octopuses, all living in total darkness. No sunlight reaches the deep ocean floor. Every ecosystem on Earth that scientists had ever studied was ultimately powered by sunlight through photosynthesis. Plants absorbing sunlight, animals eating plants, predators eating animals, the entire food chain from bottom to top dependent on the sun. But the hydrothermal vent ecosystems were powered by chemistry. Bacteria living in the vents used hydrogen sulfide from the superheated water as an energy source through a process called chemosynthesis. These bacteria formed the base of a food chain that required no sunlight at all, an entirely alternative biological energy system, powered by the heat and chemistry of the Earth's interior. Scientists described this as one of the most significant biological discoveries of the 20th century. It rewrote the understanding of where life can exist. If life can survive in total darkness at crushing pressure in superheated acidic water, fed only by volcanic chemistry, then life might exist in places we had previously considered impossible. The oceans of Jupiter's moon Europa, the subsurface of Mars, the geysers of Saturn's moon, Enceladus, all places where hydrothermal vent-style chemistry might exist. The geography of the deep ocean floor on Earth transformed our understanding of the geography of potential life across the solar system, and we found all of this in one location on one section of one ridge. The global mid-ocean ridge stretches 65,000 kilometers. Hydrothermal vent fields have been discovered in the Atlantic, the Pacific, the Indian Ocean, and the Arctic. Hundreds of vent fields have been identified, each one a unique ecosystem, each one potentially containing species found nowhere else on Earth. And most of the ridge has never been explored at the resolution needed to find them. Now let us understand the geography of everything else on the ocean floor. Between the mid-ocean ridges and the deep trenches, the abyssal plains extend for thousands of kilometers. These plains are not empty. They contain seamounts underwater volcanic mountains that rise from the ocean floor but never reach the surface. There are estimated to be approximately 100,000 seamounts on the ocean floor, rising more than 1,000 meters from the surrounding plain. 100,000 underwater mountains, most of them never seen. Many seamounts support unique ecosystems of deep sea corals, fish, and other organisms. Some seamounts have flat tops called guyots that were once volcanic islands eroded to sea level and then submerged as the ocean floor slowly sank. Ancient drowned islands. The ocean floor also contains submarine canyons, Valleys cut into the continental shelf by ancient rivers during ice ages when sea levels were lower. The Congo Canyon off the coast of West Africa is one of the largest submarine canyons on Earth, deeper than the Grand Canyon in places. It was carved by the Congo River over millions of years. The Hudson Canyon extends from the mouth of the Hudson River in New York 800 kilometers across the continental shelf and sloped to the deep Atlantic floor. It was carved when the Hudson River flowed across dry land to a coastline far from where it is today. Geography preserved in rock below the ocean surface. The Seabed 2030 project is a collaboration between the Nippon Foundation and the Global Ocean Hydrographic Commission to map the entire ocean floor by 2030. In 2017, when the project launched, only about 6% of the ocean floor had been mapped at resolution adequate to see significant features. By 2024, the project had reached approximately 24%. Progress is accelerating as autonomous underwater vehicles and improved sonar technology make mapping faster and cheaper. But even at the current rate, the 2030 target will be extremely challenging. The ocean floor is 361 million square kilometers. Mapping it comprehensively at the resolution needed to detect features the size of a small hill requires enormous sustained effort. Every year, new expeditions reveal features that were previously unknown. In 2020, 5 researchers discovered black smoker hydrothermal vents on the Nipovich Ridge in the Arctic Ocean, a slow-spreading ridge where such active vents were not expected to exist. A completely unexpected hydrothermal ecosystem at one of the most remote and inhospitable locations on Earth. Found because a research vessel happened to pass over it with sensors deployed. How many similar discoveries are sitting undiscovered on the 80% of the ocean floor we have never directly measured? The answer is we genuinely do not know. We know so little about the geography of our own ocean floor that we cannot confidently estimate what we are missing. We know the broad outlines, the general location of the ridges and trenches, the approximate depth of the abyssal plains. But the detail, the individual seamounts, the vent fields, the canyon systems, the unique ecosystems is almost entirely unknown across most of the ocean floor. The geography of Earth that remains to be discovered is not on other planets. It is 2 to 6 kilometers below the surface of an ocean that covers 71% of the world we live on, right here. The longest mountain range on Earth was hidden until the 1950s. Ecosystems that require no sunlight were undiscovered until 1977. New hydrothermal vent fields are still being found every year. 80% of the ocean floor has never been directly measured. The most extraordinary geographic discoveries remaining on Earth are not waiting on Mars or Europa. They are waiting on the deep ocean floor, right beneath our ships, in the dark. Subscribe to Where on Earth for weekly geography that reveals the world we do not yet fully know. Hit the bell and drop your thoughts in the comments below, because the world looks very different when you understand how much of it we have never seen.